Tonight is December the 10th, 2023, and I have a beautiful little McIntosh 225. I've just got to show you. It's been quite a while since I've made any audio equipment videos, but this one is definitely worth documenting. It belongs to a friend of mine here in El Paso, and for a while, we didn't trade permanently, but we traded amplifiers for a while. I'm going to use this one and listen to it for a bit, about a month or so probably. And he took a big McIntosh 225, that's that 205 watt per channel solid state amp, and he's going to listen to it, and I'm going to listen to this one. But before I get started and I get this thing all warmed up, heated up and everything, I want to show you something that's very important. Okay, this is a Mullard tube. The Mullard tubes have these characteristic little ribs there on the top. I don't know how well the camera focuses on it, but you can see a little line right there, and a little line right there, like a little rib. This is a 12EX7. It goes in the first socket. Go ahead and plug it in. This one is obviously a Mullard because it has it written all over it. It's a 10M series, which is one of the most sought after, made in Great Britain. The 10M series is one of the most sought after around. Crazy amounts of money sometimes spent for them. I put these numbers on there sometime back 84 and 88. Those are the readings of the off of the have a TV7 right here, TV7 tester. So that 84 and 88 says that's the difference between the two triodes. One triode's 84, one measures 88, so they measure very good. They measure very much alike, balanced, you might say. Let's plug that one in there. And this one, I don't know exactly who makes it. Probably Mullard, because see, it's got those characteristic lines on it too. I hope you can see that. The Telefunken, you can identify them on the bottom because they have a square in there that's kind of in the shape of kind of set sideways, so it kind of looks more like a little bit of a four-sided diamond. This one doesn't have it. This is not a Telefunken. I'm pretty convinced it's a Mullard rebranded Valvo 12AU7 ECC82. Okay, well, the point of all of this, the reason I'm babbling about all this, is these are those filaments that flash when you turn them on. And I want you to see this. There are some people out there that have made videos about these flashing tubes, and they say they're bad. And I'm here to tell you they are wrong. These are some of the finest tubes that's ever been made. These are the tubes you want. Okay? Watch this. Okay. Let's get in a little bit. I'm going to turn the light off so you can see it clearly. Okay, so it stays in focus. Now I'm going to power it up. And watch this. You see that? That's good. Those are not bad tubes. They are excellent. Okay, now that I've gone through that, that was really important for me to get out. We turned that back on. We're going to let it warm up a little bit. One of the things I'm going to show you today, I'm not going to take it apart and do all the THD and IMD and signal to noise ratio. I just don't want to do all that. But what I am going to show you is the performance difference of some tubes. They're not bad, but these two right here are vintage Westinghouse. They measure 44 over 36. 36 is the minimum, what the TV7 says. This one measures 42 over 36. These are some new Russian ones. They measure 46 over 36 and I think 48 over 36. So they measure very strong too. But I want to show you the performance of them. Now, what came out of here are these two right here. See, they say Hammond on them. They're used ones out of a Hammond organ. And they measure, I think, 22 over 46. So one of them pretty darn weak. The other one's 34 over 36. And then I'm not going to run all these in there. And here's some electro harmonics. And they all work. They're measured good, the 40/36 to 40/36. That's actually a matched pair, so to speak. Right? These two right here are just two more of the same New Russian tongue saws. They're actually quite good. I have no problem with them. But you'll see how it performs here in just a minute. And while it's continuing to warm up, I'll show you how I set it up. Okay, first of all, I like to be able to control the input voltage. I set it right on 120 volts. I made a video some time ago about how line voltage can, how dramatically it can actually affect power output and THD. So I like to control everything. So we've got it set at 120 volts. Up here are the dummy loads. Up there, those are 1% dummy loads. They're 8 ohms each. They're rated at, I think, 350 watts apiece. They're called, made by RCall. Yes, they're 350 watts. They're called an no, they're 300 watts. NH300. NH300 8R. F. Okay? NHS300 8RF. They have a almost, I would say, perfect temperature coefficient, meaning that they don't change resistance when they get hot. And I've had them very, very, very hot, so hot you can't touch it. I've got a max temperature of 390 degrees right there, and I've had it so hot before in the years past that it's turned these things, burned these things pretty much black. Okay, so the output of this thing, I'm explaining this. Those that know my videos know exactly what I'm doing here. This is the output. This is across the resistors, and this switches from left to right. So we'll start with the left channel. This output, which is across the resistor, hope you can see that. This cable right here is running over to this little breakout box right there, where I've got all the equipment hooked up. I use this to control the output so that I don't overdrive the scope. And the equipment we're going to be measuring all this stuff on is this. Okay. This is a HP 8903A. These are Tektronix SG505 oscillators. We just use one of them. This is the Tektronix AA501. It's a distortion analyzer, and this is just a voltmeter. Right here is the Tektronix DM4020 that we can directly measure power on. You can actually directly measure power on this one up here too. But we're going to do it right here, and then we'll also be looking at the output right here, and this is the frequency. So we've got frequency, power, waveform, distortion, and voltage if we want to, if we really care. Okay? This is actually what we're going to be focused on. So I'm taking this orange cable, and it runs over and plugs here right now into the left channel. We've got the gain all the way down. I got it in stereo. Got 8 ohms hooked up to it. Let's move it around here so you can actually see what it looks like. Cables are hooked up like that, and I'll be turning this with up to vary the gain for the left channel, the right channel. This is all silver plated wire. Good stuff. Okay, so let's get busy. Okay, first thing we're going to do is back off. Let's back off so we can see everything, because actually you can see things quite well in the camera, better than I can see it here in the viewfinder. Okay, we're warmed up. We're at 120 volts. We're looking at the left channel, so let's start cranking up the output. We're also running it at 2 kilohertz. Not for any particular reason. Let's run it at 1 kilohertz so we can't have any kind of discrepancy there. Okay. Okay. see, let's press auto. So we got a nice oscilloscope display. I think you can see that. There's the oscilloscope display right there. That 1.09 is actual power, average power. And right over there, there's the frequency. It's running at 1014 hertz. We're not going to split that. And right up there above that 0.0511 is its THD. There's its THD, and there's its voltage right there across 8 ohms. If you square that number right there, 2.952, and divide it by 8, you get that number right there, 1.09, or something very, very close. Okay? Now what we're going to do, we're just going to run it up. We're going to do some real simple tests here. This is the left channel. This is with those original vintage Westinghouse 7591s in it. And we're going to run it up to 1% THD. Remember, the THD is right there. So we're going to be kind of watching that one. We're going to be focusing on that one first. And then you can also be observing the power right here and the waveform right here. We're going to go off scale, so I'll turn it down here in just a minute. But let's turn it up to, well, let's check it out at 25 watts. That's what it's rated at. There it is, 25 watts. Okay, we gotta back this down. At 25 watts at 1 kilohertz. Let's kind of study it a minute. There's our waveform. Nice and clean. There's our power. And there's our THD up there. 0.07. Okay. Now what we're going to do is we're going to run it up to 1%. 1%, you'll just barely start to see some clipping. 0.4, it's at 38 watts. Can you see that? Okay, there's 2%. There's 1%, 1.08. 39 watts. And you can start to see it. Just barely clip at the top and the bottom. You see that? And there's our 39 watts, and there's our THD up there, just under 1%. Pretty darn good for a 25 watt amplifier, huh? Okay. And some really old tubes. Okay, so let's turn that one back down. Now, I'm going to show you what I'm doing here, so there's no question about it. Now I'm going to pull it out of the left channel, move it over to the right channel, and then what I do up here on this dummy load, sorry that light kind of washes things out, I just simply flip that switch here, and that goes to the right channel, goes to the other resistor. Let's see, didn't heat it up. Those are big resistors. Okay, sorry for the movement there. I know it makes some people dizzy, but I gotta do what I gotta do. Okay, the right channel. Remember, that was with those old Sylvania 7591. Now here's the right channel. It's coming up. Let's do it. Let's check it at 25 watts. There you go, 25, a little over. Just slightly over. That ain't bad, huh? Beautiful waveform. Let's examine it a little bit. There's our waveform. A little washed out because of the, here. Let's see if we can make it a little better there. There we go. That's actually better all the way around. And there's our 25 watts. And there's our THD, 0.07. Very good. And that's with the Russian tubes. That's with the Russian 7591s branded Tungsol. I like them. I use these in my Williamson amplifier. I'm not here to chunk rocks at anything. I'm really not. But I'm going to show you a difference here. Now let's run it up to 1% and see what we get. Okay, we're back up here looking at this one again. We're going to watch that one up here. We're going to run it up to 1%. 0.3, 0.8, 1. It's really touchy. 1.14. That's close enough. Oh, it's doing really quite well. We get 32 watts. Okay, and you can see again, just the slightest bit of clipping at the top. 32 and 1%. So I'm a fan of those Russian 7591s, and I just ordered another set for it. The other set of 7591s don't. The other two sets, the other U.S. set and the other Russian-made Tungsol set, do not perform quite as well. But they all definitely meet their specs. They have 25 watts per channel for a little amplifier for a really jewel. I mean, some people say this is the holy grail of of stereo amplifiers if you've got efficient speakers. It was serviced. Actually, my friend bought this, and I think it came from Holland, one of those, one of the countries over there, one of the countries close by. I don't remember exactly where it came from. I think it was Holland. But it had been serviced in the U.S. by some well-known service company, and it's all documented underneath. They did an excellent job. So this one is in fine shape. You want this one. If it just had its cover there, it'd be worth like $1 million, wouldn't it? Well, anyway, that is documentation of a beautiful little 25 watt per channel Mac amp. I'm going to turn it off here, and no, I'm not going to turn it off yet because I might want to do something, heavens knows, so I don't have to get back on and off. Really performs quite well, doesn't it? But the little USA tubes are, if you can really luck out and get some good ones, they still seem to always perform the best. I don't know what else to say about that. It seemed like there were several other things I wanted to point out, but I don't remember what it is. So I'll let it go at that. The McIntosh 225. Thanks for watching. It's almost Christmas, so everybody stay safe. God bless.